Hi everyone, thank you for joining us today. In this session, we'll be going through how you can get connected with Wandera APIs and data streams. Today we'll be covering what integration points are available for you to connect to Wandera datasets and the key differences between them, how you can do this in practice, and what use cases you may want to do this for. My name is Milind Patel. I'm a product manager here at Jamf, and I joined Jamf through Jamf's acquisition of Wandera. I'm responsible for our mobile threat defense product, though, as well as threat defense, I've also had the pleasure of working with our engineering teams to build our data streams and our risk API. If you have any questions about APIs or integrations relating to threat defense, data policy, or private access, please add them to the chat, and I'll do my best to answer them as we go through this presentation. So, what is Wandera? Wandera has been a leader in mobile threat defense and data policy since 2012. Over the years, we've been consistently rated as a leader within the MTD space by analysts and trusted by reputable organizations in both the public and private sector to protect their devices and their data. Wandera was acquired by Jamf in July of this year, adding a great new set of capabilities for you to protect, manage, and connect your users to the apps and the data they require to be productive. With Jamf Threat Defense, you can provide endpoint protection for your mobile devices. With Jamf Data Policy, you can provide content filtering and implement data usage controls. And with Jamf Private Access, you can provide your users with secured access to business applications using Zero Trust Network Access technology. In this session, we'll cover the data integration points specific to these products, and when you hear the term Wandera anywhere, it'll be used to refer to the technology pertaining to these products. For more on this, check out the session Introducing Wandera by Michael Covington. For detail on any product specifically, there's a deep dive session for Jamf Threat Defense, Jamf Data Policy, as well as Jamf Private Access that you can check out. We have three means of helping you to connect your data: data streams, a risk API, and an integration with AWS S3. Today we'll be covering data streams and the risk API. The S3 integration is often used by our customers with specific data retention or data handling requirements, but that requires us to give you a helping hand right now. Don't hesitate to reach out if this is something that you'd be interested in. First, let's talk data streams. Our data streams are all about letting you know what's happening as soon as it happens. Currently, this is done via Ceph-encoded syslog over TLS. This has allowed us to support a wide range of third-party security solutions up until now. In Q4, we'll also be adding support for sending HTTP events in JSON format in order to support more plug-and-play integrations than ever before. And we will continue to add these new capabilities as we discover new use cases that you care about. We currently have 4 data streams: the threat event stream, which hosts all threat detection events flagged by Jamf Threat Defense across multiple attack vectors; the network traffic stream, which hosts all network traffic events captured by a security cloud, if you've chosen to add a cloud proxy or secure DNS traffic vectoring element to your deployment; the app insights stream, for any app vetting insights into the applications installed on your mobile devices; and the devices stream, for visibility into your mobile device state and the latest state of the devices. The latter two, the app insights stream and the devices stream, are currently only available to our partners. However, if you're interested in integrating with them, definitely reach out to your account rep or myself in order to discuss this further. So, where can you send the data? Right out of the box, you have documentation available for you to start connecting your data streams to popular third-party solutions such as Splunk, Azure Sentinel, Microsoft Cloud App Security, and many more. If you have a more custom use case, you can easily set up a syslog or HTTP receiver in your own environment to be able to start ingesting these events. We only require that this is encrypted with TLS so that your server is able to present a certificate known by a known public CA. We do this to ensure that your traffic and your data can be encrypted and kept secure while in transmit. And we're more than happy to work with you to help you maintain the best security practices possible. Now let's get on to setting this up. Here we have an example with a network traffic stream, which hosts web traffic log data. If you already have a syslog or HTTP receiver capable of receiving these messages, then the setup on Radar, our admin console, is super simple. First, just tell us where this data should be sent by adding the destination hostname and port. Second, test the configuration to make sure that we're able to establish a connection and there's no issues with the config. Finally, just enable the stream and save everything. From this point, the network traffic stream will start to send the log data to a configured third-party or on-prem server, and this will all happen in real time. We've kept the basic setup process, as many customers will only need to do these steps, and you can get set up very quickly and easily. Aside from this, we also have many optional configuration options to add further security and supportability to the streams. On the security side, by enabling client authentication and adding the Wandera CA to your receiving server, you're able to ensure that only messages coming from the Wandera data streams are accepted. You can also take this further by only allowing inbound connections from our IP addresses with your network access control policies. If you've chosen to use the syslog option, you can choose the event framing that is used for these messages. By default, this uses octet counting. However, some older tools may not support this, so you can switch easily to non-transparent framing where it's required. Lastly, you can customize your log messages to select the exact data points that you care about. This helps with saving costs on data, but also with data privacy, as you don't need to choose between all data and no data. Another option to make this easier to ingest this data is the ability to rename the field names to some other values. By doing this, it can often make it easier for your third-party system to index and map the incoming data. So, what are we actually streaming? As you can see, the network traffic stream, understandably, is the busiest one, processing over 4,000 events on average for a customer with about 100,000 active devices. The other streams are comparatively much lower, though still generating a lot of useful events for insights into new threat detections, risky or unwanted applications being installed, or simple device state changes. As mentioned earlier, all of this is then sent securely while making sure that we're able to recover and re-push any messages if we detect that your event receiver is down. Getting everything configured is all well and good, but what's the point of it all? Generally, each organization and their teams will have their own unique use cases that they care about. Some of the most popular ones that we encounter, though, are consolidating data to provide unified reporting on all of their assets and data, responding to threat detections with further action, ensuring employees are using approved and secure applications, and discovering new underlying threats and risks. If you're interested in learning more about some of the security use cases that I've mentioned, check out the session here, where I'll be talking about what you can do with the data once it's in your SIM or other SOC tool. Finally, our Risk API is a bidirectional REST API that can be used for accessing device risk data. While the data streams allow you the ability to send events in real time, this API allows you to access and affect the device risk state. An API is essentially an intermediary that allows two applications to talk to one another. In this case, your custom applications or your third-party tools and Wandera through the Jamf Security Cloud. A RESTful API design determines what the API looks like and allows developers to easily work with different APIs that follow the same principles. In the simplest terms, this works by an application making a request to another application and receiving a response based on that in return. The Risk API currently consists of three distinct endpoints. The first, the login endpoint, allows you to authenticate your application before it's able to access your data. This is crucial in keeping your data secure. The second, the devices endpoint, allows you to obtain information about your devices that are deployed with Wandera capabilities. The third, the override endpoint, allows you to override the current device risk based on any context that you wish to use. This is often used for conditional access with Jamf Private Access. Now on to the fun part, using the API. Getting started is simple. Just head to Radar and navigate to Integrations, then the Risk API. Here you're able to generate a new API key or revoke an existing one. When you generate a new API key, you'll be asked to name it for easy identification in the future. Once you've done this, you'll be given an application ID and an application secret. Make sure to note down the secret, as it will not be visible again. Once you've got your basic credentials, you can call the login endpoint to get your token. You can do this by making a call to the login endpoint using basic auth with the application ID as your username and the application secret as your password. This will give you a JSON Web Token, or JWT, which will authenticate your other calls. For security reasons, each token is only valid for 15 minutes. and will need to be renewed simply by following the same steps all over again. Once you have your token, you're ready to start making calls to other endpoints. For example, when calling the getDevices endpoint, you will set the authorization type to bearer token, with the value being the token you received from the previous login endpoint. A successful call here will result in a 200 status code, and you can see that you're able to see your requested data. Now let's take a look at what the response shows. Each device record will show the device identifiers and the risk state, deployment and activity status, as well as the sync status with a UEM, like Jamf Pro, if this is a managed device. Finally, in the response, you can also see pagination information if the returned dataset is large and needs to be split up. You can navigate through the pages by using the endpoint parameters, page and page size, in order to retrieve all of your data. Now let's see it all in action. Here's a demo showing you how a simple script will call the login endpoint to get the token, call the devices endpoint, run through the paginated responses to get data on all of your devices, and output the high-risk devices. Once this is done, this can be extended to take specific action for these high-risk devices or forward it elsewhere as it's required. The override endpoint works similarly to the devices endpoint that we just saw. However, this one allows you to change the data, specifically the risk state of a device. With this endpoint, you'll need to provide a payload telling the API what needs to happen. In this example, we're setting the risk of the listed device to low, with the source being manual as we're setting it. You can include multiple device IDs here if you need to make a bulk change. And a successful call here will result in a 204 no content response, telling you that the payload was accepted. Another call with a slightly different payload will reset everything back to normal. Here we set the source to Wandera, meaning that for the listed device, we want to have the risk calculated once more by Wandera's risk calculation algorithms. What can you do with the Risk API? You can use it for automated risk assessment. You can use it for compliance reporting if you have specific requirements in that area, or you can use it for conditional access to sensitive corporate applications. What does this look like in practice, though? Let's take a look at a demo showing you how powerful the Risk API can be when used with Jamf private access and risk-based access policies. Here we'll create a risk-based access policy for Google Apps and define the policy to block any high-risk devices from accessing these Google applications. Let's see this in action. As with all Risk API steps, we start with creating an application, which will give us an application ID and secret. For now, we'll use the one that we've already set up before. Now we'll create a risk-based access policies for Google applications. Within this policy, we'll define that only applications which are medium risk or below are able to access this application. So high-risk devices will not be able to access Google Apps, such as Gmail, Google Drive, and others. If we go to the security screen, we can see what the current state of this particular device is that you see on the left-hand side. We can see that it's medium risk, so it should be granted access to Google applications like Google Drive, and the device is able to access confidential data within it. Now let's use the API to adjust the score to mark the device as high risk. First, we'll use the login endpoint to get the token, and then we'll use the token in order to authenticate ourselves against the second endpoint in order to override the current device risk and set this to high. If we refresh the page, we should now be able to see this change being reflected on the security screen. Now that the device is high risk, let's see what happens when the device tries to access the same resource once more. As it's a high-risk device, we should expect that this device should no longer be able to access confidential data within Google Drive. And we can see that it's blocked from doing so. Depending on the admin's policy, the user at this point would also receive a push notification to let them know why they weren't able to access a particular resource. Now let's take it back and revert the change, and once more start using the Wandera's risk calculation and see if the device is able to access the resource now that it's back to being medium risk. So If we go again to Google Drive and try to access the confidential document, you should see that the device is now able to do that. I'm afraid that is it for this session. I hope this session gave you insights into how you can connect with Wandera data streams and the RISC API, and it gave you some inspiration for your own use cases that you'd like to power through them. I wanted to thank you all for attending today. Don't forget to hit the like button and subscribe if you want more content. Thank you.